G'day legends, we're going to be looking at symmetry today. We're looking at rotational symmetry, and we're looking at finding lines of symmetry in 3D shapes. This is a really tricky task, so good luck, and please watch this video again if you're unsure. Alright legends, good luck. G'day Mass Legends, today we're looking at symmetry. So we're going to start off with reflection symmetry. So that is when we can cut a shape in half, and then if you fold it over, it looks like the other side. So it's similar to what you guys did when you were younger in grade prep, when you did your little butterflies. So if we look at these shapes here, we can see there's a reflectional symmetry. So when we reflect the other side of this shape, it reflects on the other side, and that's just a simple symmetry. So we can see the line of symmetry here, okay? We can see the line of symmetry there. On the next shape, we've got a square, okay? And we can see there are a few lines of symmetry through that. We've got a nice vertical line, we've got a horizontal line, and we can see that we've got two diagonal lines. That means if we were folding it along that line of symmetry, it would be an exact, it's half. Looking over here at the reflectional symmetry of a triangle, we have three lines of symmetry. We've got one, which is the vertical, and then we've got two diagonals, okay? So if we were to fold it in half at that point, we would be able to, we'd have, all the ends would meet up. Then we've got, over here, we've got a rectangle, and we can see that we go vertical and horizontal for that one. Now, the bigger one, the more challenging one is rotational symmetry. And that's when we rotate an image around. And I'm going to go through that in the next activity a little bit. But if you look at this rotational symmetry, that means that if I was to rotate that around this way, it would remain the same. So this would then still look exactly the same, okay? I'm going to show you a couple of little hacks and tips of how we're going to do that. All right, good luck. The one thing I want you guys to remember is that when it's rotational symmetry, when the image is rotated around a center point, so there's my center point, so it appears two or more times. So if I was to rotate this shape 90 degrees or 180, it would always look the same, okay? So as I put that shape around, okay, it'll always look the same. Here is my rotational symmetry. I can put a little circle there. I could rotate that once, twice, or three times. All right, legends, good luck. All right, legends, just looking at simple lines of symmetry here is we've got a couple of shapes here. And what we're going to do is we're actually going to draw a line where the lines of symmetry are. So if I go through the vertical, okay, I've got a line of symmetry there. I've also got a horizontal one there. Okay, this shape is quite tricky though, because I've also got diagonal lines of symmetry. Okay, so I can draw my shape just like that. Okay, so in total, this line has 1, 2, 3, 4. 4 lines of symmetry. 1, 2, 3, 4. Okay, now this also has rotational symmetry, because as I rotate that, I will always have the same, as I turn it, it will have the same lines there. So what I mean by that is if I put a little dot at the top of this shape, just here, and I rotate this, as I rotate it, it'll look the same. That little dot might be pointed over here. So if I go 90 degrees like this, okay, this shape will still look the same. Okay, so this has rotational symmetry, and it has line symmetry. All right, so I'm gonna put A up the top there. The next shape has got symmetry, okay? It's got line symmetry, okay? As I'll go through there, and I can do this and do that, it's got line symmetry. But that shape also, okay, as I rotate that through, that also has rotational symmetry. So I'm gonna put a B there too, okay? This shape here, now, this shape, does it have a line of symmetry? Well, yes, it does. If I fold it through here, it has line symmetry. But if I was to rotate this shape around, just with rotational symmetry, I would then have an arrow facing down here, okay? Now, this shape does not have rotational symmetry, okay? Because as I turn this shape like this, if I turn that 90 degrees or 180 degrees, okay, that shape will completely change, all right? So that shape does not have rotational symmetry. So I'm just going to put line symmetry there. Finally, the shape at the very end, if I was to rotate this shape 180 degrees or more, it will always look the same. So shape D has line symmetry, because if I was to line through here, or a line through here, or a line through here, or a line through here, it all has lines of symmetry. So the only shape that doesn't have rotational symmetry is C. All right, good luck. All right, legends, so I'm going to show you a great little hack when we're all rotating things. So we're going to be rotating these shapes 90 degrees. So just like we're doing angles, 90 degrees is just a quarter turn. And I'm going to be showing you how to do this. Now, the big hack that I want to go through, you guys, is to put a little dot at the top of the corner, okay? So when I rotate that, I can now track where that shape is going. So let's look at the first one. I've got my triangle, okay? I've got a right angle triangle. And as I turn that 90 degrees, I'm going to rotate it around so it's 90 degrees. You can now see that that dot is now pointing that way, all right? So this gives us, it allows us to track how our shape's rotating. So I'm going to do the same thing with this pentagon here. So I'm going to get my pen. I'm going to put a little dot there for him, okay? And I'm going to rotate that shape 90 degrees. So as I rotate it around, you guys can see that that dot is now facing a new direction, okay? So I know this helps me keep track of where I'm rotating that shape. Let's look at the next one. I grab this shape, okay, and I simply, I start off, I put my dot down, put my little dot at the very top. I'll do that to the bottom one underneath it as well. And then as I rotate this shape around, I can actually track where that dot's going to, okay? And then I can do exactly the same for this one, and I can rotate that shape, okay? So you can now see where that little yellow dot is, all right? What I might do, so you can see now that where I've rotated all by 90 degrees, you can see that little dot has gone from this location to here. Down the very back here now, we're going to rotate these shapes by 180, okay? So again, I've got my little dots at the very top of those. So as I'm going to grab my shapes, I'm going to rotate this 180 degrees. So there's 90, and then there is 180. So I'm just going to turn that, I turned it a little bit too far. So there's 180, okay? This shape is going to get one down below here. You can see where that circle's at the top. That's nice and easy. That makes this one easy because I know that if I'm turning that 180, that circle, that little dot is going to be down the very bottom. Okay, so just like that. Then finally, the next shape is the arrow. The arrow is pointing up. I rotate this shape 180 degrees, okay, and I turn it around just like that. And the L, I can see where the yellow dot is. I turn that all the way around 180 degrees, and then there you go. So that's how we work rotational symmetry. Always put those dots there. Big hack. All right, guys. Good luck. Okay, the last part we're going to look at is cross sections. And what cross sections are is that if I was to cut these shapes in half as they look here, I've got a little line where it's got a plane that's cut through that 3D shape. What would the face on top of that shape look like now? So you can see it's actually there in like a dotted line, you can see, but the face is generally the same as the top of the face. So the face where the cross section is generally the same as one of the ends, or the faces at the end. So this shape here is actually a pentagon. So the cross section for this shape is the same as a pentagon. It actually is this one here. Okay, let's look at the next one. So the next one here is they've cut a triangle in half. And you can see in those dotted lines, you can see that there are 3 ends, okay? Now, if I was to cut that triangle in half, even though it's a square-based pyramid, I'm actually cutting it in half. And as I cut that in half, I'm gonna have the bottom, which is the square, but then it's gonna end in that triangle, giving me a triangle, okay? So that shape is gonna meet up with that one there. Look at the next one, I have a cylinder. My cross section for a cylinder is if I cross section, if I cut it in half at that point there, okay, then I'm going to look that I can see the dotted line, there's a circle there. I'm now going to add this and connect that to the circle. All right, looking at the next one, please. I've got this shape here. Now you can see that it's not going straight through the middle. It's actually getting cut at a diagonal. As it gets cut through a diagonal, it actually changes what the plane is going to look like. Or as the plane cuts through it, it's going to change what that face looks like. It's slightly like a circle, but it's on a lean. That gives me an oval shape, okay? So that's that shape there. Finally, looking at the last shape together. this is a rectangle. And as the plane goes through it, okay, as the plane cuts through it, I can see that the face is now a square. The face is now a square. Well, possibly a little bit more of a rectangular shape. From my perspective, if I cut through it at that point there, it's a square, but I don't have a square here. The closest one I've got actually is a rectangle. I believe this is more of a square than anything else. So I would want to cut this or put the line through here to give me my nice square, because I believe it's a square, but that's okay. That's just Mr. O'Shaughnessy being a bit pedantic. So as I go through here, I then rule that shape to here, okay? And then that's connected that way. All right, guys, good luck with your sums. I hope this makes sense. Feel free to watch it again if you're unsure.